Mollusks and arthropods are organisms found in the intertidal zone of the seashore. Specifically, they are phylas derived from kingdom Animalia. Mollusks are characterized as having an internal or external shell, while arthropods possess a chitinous exoskeleton with jointed appendages. For this Group 4 project, we designed an experiment to conduct at the Northeastern University Marine Science Lab. We are interested in investigating the relationship between seawater salinity and the prevalence of arthropods and mollusks.
Our hypothesis is that the ratio of arthropods and mollusks will increase as the salinity increases. For our independent variables, we have the different intertidal areas with seawater salinity differences, high tide, low tide. For our dependent variables, we have the ratio of the number of arthropods and mollusks found in the quadrant. For our control variables, we have the area of reference marked by the quadrants. Our materials include quadrants, hydrometer, refractometer, phone/camera, a guide, a pen and notepad, and a thermometer.
For the procedure, first we defined where high tidal zones and low tidal zones are located. Next, we chose, for each independent variable, where to set up the quadrant to conduct the trial. Moreover, we counted the number of arthropods in the quadrant. Then, we counted the number of mollusks in the quadrant as well. Furthermore, we measured the temperature of the reference area with a thermometer. In addition, we measured the salinity of the water with a refractometer and a hydrometer. Lastly, we recorded the data in the field notes and compared the ratio of organisms for both phyla.
The first 5 samples were recorded in high tide. In sample 1, the specific gravity recorded were 1.024 and 1.025. The number of arthropods counted was 9, while the number of mollusks was 14, and the temperature recorded was 19 degrees Celsius. In sample 2, the specific gravity recorded were both 1.024. The number of arthropods counted was 19, the number of mollusks counted was 88, and the temperature recorded was 19 degrees Celsius. In sample 3, the specific gravity recorded were both 1.024. The number of arthropods counted was 9, while the number of mollusks counted was 44, and the temperature recorded was 16 degrees Celsius. In sample 4, the specific gravity recorded was 1.023. The number of arthropods counted was 6, while the number of mollusks counted was 54, and the temperature recorded was 16 degrees Celsius. In sample 5, the specific gravity recorded were 1.025 and 1.023. The number of arthropods counted was 3, while the number of mollusks counted was 21, and the temperature recorded was 16 degrees Celsius. The other 5 samples were recorded in low tide. In sample 6, the specific gravity recorded was 1.025. The number of arthropods counted was 11, while the number of mollusks was 73, and the temperature recorded was 16 degrees Celsius. In sample 7, the specific gravity recorded were both 1.024. The number of arthropods counted was 11, while the number of mollusks was 41, and the temperature recorded was 19 degrees Celsius. In sample 8, the specific gravity recorded was 1.023. The number of arthropods counted was 2, and the number of mollusks counted was 32, and the temperature recorded was 16 degrees Celsius. In sample 9, the specific gravity recorded was 1.022. The number of arthropods counted was 2, while the number of mollusks counted was 19, and the temperature recorded was 16 degrees Celsius. In sample 10, the specific gravity recorded was 1.025. The number of arthropods counted was 7, while the number of mollusks was 52, and the temperature recorded was 18 degrees Celsius.
During our experiment, we made a number of observations. The first, in each tide pool, there was a considerable amount of porifera and abundances of marine seaweed around and in the tide pools, especially in the lower tides. Number 2, the more shallow the tide pool, the considerably warmer they were. Third, arthropods are more numerous in rocky tide pools and were often found under the rocks. And lastly, the more area in a tide pool, the more organisms were present.
Use both hygrometer and refractometer in each trial to measure seawater salinity. Therefore, we collected 20 data points over 10 trials, greatly increasing the accuracy and validity of the experiment. Difficulty of determining high and low tide at the seashore. So we chose 2 independent variables are not distinguished clearly. A certain distance from the shore could be determined as high tide. Limited areas of ponds with discernible mollusks and arthropods. This restricts our choices of location to carry out the experiment. Difficulty in counting mollusks and arthropods because of quantity, movement, and discerning dead versus living creatures. Having multiple classmates counting the organisms to eliminate the amount of errors. There may have been several organisms that were not visible and or hidden, especially since our movements surrounding them could have triggered this. Having a light to show the areas that are darker in the tide pools to see better, along with being more quiet and less disruptive when approaching the tide pools. Tampering, though unlikely, could have changed the data, such as disruptions caused from other groups and other experiments. Having chosen distinct tide pools that haven't been observed recently, approximately 30 minutes, by other groups.
This experiment aims to investigate the effects of salinity on the ratio of mollusks and arthropods. The study was carried out in the seashore in both high tide areas and low tide areas. The temperature, specific gravity, the number of mollusks and arthropods are recorded in 10 trials. Our findings show that the ratio of mollusks and arthropods have no observable trend against salinity. Limitations of our experiment include environmental constraints, experimental methodology limitations, and personal and random errors, which decrease the validity of our experiment. Overall, our hypothesis was correct, though with working with classmates, each from a different science was interesting and beneficial to our group in our continuous advancement into the IB.